You look at these three curves. Are you able to see it?
Yeah.
Okay. If you look at these three definitions of the curves, what is the left-hand side giving us? What is the PU?
Function of the curve. Oh yeah, that's the function of the curve with respect to the u, which is.
So it's an infinite number of points along the curve.
Yes.
Right?
Exactly.
Right. And it's defined in the context of what? A handful of points that define the control net of the curve and some blending functions. So if we look at the right-hand side, all of them are a summation, a group of terms, and the terms are a point times a blending function, another point times another blending function, and so on. Hopefully you can kind of just look at that and see that representation in all three of them. Some of these curves interpolate the endpoints. Okay? In fact, all of them can be forced to interpolate the endpoints. Most of the other points on the control net do not touch the curve. Okay? So they don't touch the curve. They're not on the curve. On some of these curves, we've learned that the first 2 points and the last 2 points define what? The vector between the first 2 points, the vector between the last 2 points of the control net do what? Define the tangency at the beginning of the curve or the end of the curve. Okay? So we can very quickly compute, very easily compute kind of the tangency at the beginning or end, knowing just the point, the first point, the second point, the nth point, and the nth minus 1 point will give us kind of the slope at the beginning and end. Okay? We also talked last time how in the CAD systems, we can go in there and define a number of points, and those points that we define can represent the control net, but frequently that's not the default. Frequently the default is click, 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 and what does the curve do? It goes through every one of those points. But it's called a NURB, or it's called a B-spline, or it's called a Bezier, but it still goes through all of those points. Okay? To help us kind of understand the mathematics of how it's going through all of those points and still being called a NURB, because in effect, every time we click a point, it's filling in the left-hand side of this. Okay? If we're just doing 10 points and the curve goes through those 10 points, we're kind of filling in the left-hand side of these equations, not the right-hand side that we've been talking about. Okay? Unless we have it turned on to where we're putting in control points. And if we're putting in control points, then we're filling up the right-hand side of these equations. So we need to jump over to page 3, where it starts talking about splines. So the definition of our spline is, again, PU. So an infinite number of points go on the left-hand side of this. On the right-hand side, it's the summation of I equals 0 to n of an AI UI. Okay. And when we expand that out, we just get A naught u to the 0th power, A1 u to the first, A2 u squared dot dot dot, an to the un. And so it's a polynomial of nth order, and it's nth order based on how many points we give it, right? Okay. So if we're looking at this, what do we know? Well, we know a bunch of PUs. Okay, we can choose them. Here's 4 points that we want to go through. So we know the PUs. We also know the spacing. We know that we want the curve to begin at the first point. We want it to end at the nth point, or the 4th point, or whatever we have. Okay, and we know that it goes through these other points. Well, how far is it from the first point to the second point? Well, if there's 4 points, what's a good U value for the second point? 1/3 of the way along, right? And what's a good value for the third point? 2/3 of the way along. And for the fourth point, it's all the way there, it's 1. Okay, so in effect, because we are the engineer and we're placing these points, we can figure out what the U's are. Okay, so what don't we know? Well, in that equation, the thing that we don't know are our coefficients. Our coefficients are unknown. And so if we want to try and solve for that, how are we going to go about doing it? Well, let's assume that we just have 2 points. Okay? So we're going to have 2 P's. We're going to have a bunch of U's that we know. And we're not going to have any A0 or A1. So 2 unknowns, A0 and A1. We can get 2 equations. What are the equations going to look like? Well, if we're just dealing with x of the line, so we're getting the x mapping function, we can put our first x value in, okay? We can put in our second x value, and we can get this equation where the u's are u to the 0th power, u to the first, u to the 0, u to the first. When we're at point 0, when we're at 0, where do we want this u to be? What do we want the value of u to be? We want the value of u to be 0. U to the 0 to the 0th power is what? 1. 0 to the first power is 0 times our coefficients. Our second equation, we now want u to be what? 1. U to the 0, but u is 1, so 1 to the 0 is still 1. U to the first, where u is 1, we get 1. And so those are our 2 equations that we have to set up. The problem is we don't know what A is, so how do we isolate A? Well, we multiply U times the inverse of U to get the identity matrix. Multiply P times the inverse, and that will give us our A values. Once we have A, so we solve for A, we plug it back into the original equation, and now we can find any point along that line. We just choose a different U. We choose a U of 0.25, and it will give us the X value when U is 0.25. We choose a U of 3/4, and it will give us a U at that location, okay? So we have to kind of solve the inverse problem to find our coefficients and to basically work from there. So now what we're going to do, well, I forgot I worked it out. So we took the inverse, we multiply it times, and we get P0, 0, okay? equal to A, that equal to A1. We plug it in, and once we plug these values back into the equation, notice we get the equation for a line, which is exactly what we better get, right? A line that is a spline, a line that is a Bezier, a line that is a B-spline, a line that's a NURB, ought to look exactly like this equation, okay? It ought to be that same thing, okay? And so it works. What if we're given 3 points? So those are the 3 points, 1, 2, 3, 5, 3, 5, 1, 7, 2, 0. How do we set up that problem? So here's our equation. 1u, u squared, times a naught, a1, a2. What do we know again? Well, we know the PUs. We can figure out what the U's are. We don't know the A's. So we're starting, so we're just doing X. So 1, 3, 7. For this number 1, what are the corresponding U's? Well, the corresponding U to our first point is U equals 0. We plug that into 1 u squared and we get 1, 0, 0. So our first equation is really going to be just A naught equal to 1. Our last point, 7, U is equal to what? 1. So we can put in 1, what is 1 to the first? 1, what is 1 squared? 1. We take that, multiply it out, and our equation becomes A naught plus A1 plus A2, okay, for this last one. What about 3? Well, we're the engineer. What do we have to decide? We have to decide how far along the 3 is. Did we take it halfway along this path? We're inspecting, we're clicking points on the screen. Did we click that point roughly halfway along? Or exactly halfway along, okay? So we have to decide what U is. Well, let's assume that U is halfway along. I think that's what I assumed. I lied. I assumed it was 1/3 of the way along, okay? So being 1/3 of the way along, 1/3 to the 0th power is still 1. 1/3 to the first is 1/3. 1/3 squared is 1/9. We fill those things in. Question?
Is that 1/3 just chosen based off the points you have, or chosen based off your own guess?
Okay. It's based on, if you're inspecting a surface, then you're going to say, I'm going from here to here in X, that far, and I've come a halfway along in X, I've come 1/3 of the way along in X, so you're kind of deciding, and by deciding that, you're actually influencing the shape of the curve. Because with choosing 1/3, the length of the curve from point 0 to point 1 is going to be 1/3 the length of the X mapping function. The other part of it's going to be 2/3 long. So you're influencing where that point is actually falling. Okay. We take the inverse of it, we kind of slam it in there, and we get a mapping function equal, so the X mapping function is 1 plus 6u. And if we do the same thing for Y and Z, we get those values. Okay. Question?
When you do Y and Z, I'm assuming you have to use the same U's. You can't choose like a new U, like choose a half for the middle one instead of a third.
If you were actually doing the inspection